Hi everybody, I'm Hayley and I want to share some of my data looking at host-parasite behavioral interactions between laying hens and northern fowl mites. So under the 5 domains lens or the framework, we have nutrition, physical environment, health, and behavioral interactions that all ultimately affect the animal's mental state or their affective state. And it's this state that ultimately determines the animal's welfare. I'll be focusing on the behavioral interaction lens, which has 3 main components. Under behavioral interactions, we have interactions with the environment, interactions with other animals, but also interactions with humans. So for laying hens, this could be them interacting with their cage-free systems, with other laying hens that they're with, or with caretakers that are seen around the farm. Now, I want to introduce our villain of the story, which are going to be the northern fowl mites. So these guys are already the most prevalent ectoparasite of our North American laying hens. They're a blood-feeding type of mite, so they're living permanently on their host, in this case the laying hen, and they're feeding on the laying hen's blood. Because of their ecology, they prefer to live on the hen's downy vent feathers, mainly because of its nest-like microclimate, but also it's kind of a hard area for the hen to reach. They have a really rapid population growth because they're haplodiploid, so a single female mite is able to kickstart an entire infestation on her own, which is really, really problematic. Addition to that, we also have that our infestation level is highly variable. It's heterogeneous. You can have 2 laying hens in the same environment, give them the same number of mites to start, come back in a couple weeks to count, and they will have widely different numbers of mites. And so this is what makes it really difficult to treat and control these mites. So I have my video here. I love showing this video. Some of you are probably sick of seeing this by now, but this is a hen with a really high infestation level. So you can see the debris in the feathers is a mix of mites, fecal material, eggs, skin shedding from the laying hen, things like that. That flake of skin you can somewhat see toward the middle of the screen is part of the hen's immune response, and that's how she's combating these ectoparasites. You can see that they're really, really small. They look like little flakes of pepper. So this is what allows them to have such large populations in such a small area, but it also makes it really difficult to quantify how many are exactly are living on the hen. And so most of all, they're costly to our egg industry. So we found that northern fowl mite infestation can result in losses ranging from 7 to 10 cents per bird over 10 weeks. And when we think about the production cycle of a laying hen, which can go up past 100 weeks, that's a lot of money in the long run. Northern fowl mites are also only becoming more prevalent as we're shifting to cage-free production just because it's much easier to spread and much harder to control. Infestation has negative effects on our productivity measures. We see reductions in egg production and feed conversion, lowered body weights, and an overall increase in mortality. So this brings us to the question of what tools do our birds have for combating ectoparasite infestation? And like most things with studying chickens, the wild bird people are way ahead of where we are. So in the wild bird literature, we're able to see that they have evolved strategies for combating ectoparasites. Starting off with body maintenance, these will probably be the behaviors you first think of, things like preening, allopreening, scratching, and dust bathing. There's tolerance behavior. So instead of trying to avoid the negative effects, they compensate for them by increasing feed intake to offset those energy costs. For nest maintenance, they can avoid nesting in dense ectoparasite locations, or there has been literature showing that birds will comb through their nests to remove ectoparasites using their beak. And another thing they can do is migrate. So this is a spatial and temporal avoidance of ectoparasites. If you know they're going to be in an area at a certain time of year, just don't be in that area at that time of year. So this is all well and good for our wild birds, but it's much different for our domesticated birds who are living in houses where you can't escape ectoparasites the way you would in the wild. So translating this over to our laying hens, looking at body maintenance behaviors like preening, we see that there's an increase in the number of occurrences, but there isn't necessarily a change in duration when it comes to poultry red mite infestation. Red mites are a similar ectoparasite of laying hens, they just don't reside fully on the hen. They live in the environment and come on the hen to feed, but they're both blood feeders. When it comes to lice with laying hens, there is a positive correlation between grooming acts and the number of lice. So the more lice you have, the more you're grooming. Looking back at northern fowl mites, there was an increase in the frequency of preening when there was an increase in the infestation level. So again, more mites is going to mean more preening. And there's also an increase in vent-specific preening duration. So not only are they going to be preening more, but they're going to be specifically targeting the areas where their ectoparasites are residing. Looking at dust bathing, again, there's an increase, in the frequency of the behavior when we have a higher infestation level. And some work from our very own Dr. Jacobs has shown that there's an increase in general activity and preening, but a decrease in dozing and sleeping behaviors overnight for laying hens. So this is quite literally disturbing them and keeping them awake at night and not enabling them to sleep and rest as really important for a laying hen and for producing her egg. So if we put this back under the behavioral interactions lens, an infested hen can interact with other hens in her environment, she can interact with herself, or she can be interacting with the mites that are residing on her vent area. So what we sought to do on the study was to characterize the effects of northern fowl mite infestation on our laying hens by examining the effective infestation level on laying hen behavior parameters. So starting off with how we quantified how many mites we had, our mite scores were determined in a 4 by 6 centimeter area anterior to the cloaca, which works out to be about the size of this box. This is the location where most mites inhibit, which is why we selected it. And it's also because it takes a long time to assess the entire hen. It's about 5 minutes. And we had hundreds of hens on this trial that all needed to be counted. So we had to somewhat restrict our area of counting just for the sake of time. Mites were counted weekly on a subsample of hens, and they were counted on all hens at each welfare assessment period. And then in between these assessment periods is when we used the subsample counting. The scale or the scoring system that we use is logarithmic, where a score of 0 means 0 mites, score of 1 is between 1 and 10 mites, going all the way up to a score 7, which is over 10,000 mites. When it came to selecting our focal hens for video observation, the hen in each pen with the highest level and the hen in each pen with the lowest level of mites at the peak of infestation was selected for behavior observations. For our high group, this meant that all birds had over 101 mites, with the majority of them having over 1,000 mites residing in this 4 by 6 centimeter area. For the low group, they all had fewer than 50 mites, but the vast majority had fewer than 10 mites, again residing in this 4 by 6 centimeter area. So the way we did this was we had our 400 hens on the trial. It was at 24 weeks of age that we infested them with 50 fowl mites per hen on the vent area. Everybody received the same treatment. We selected our focal hens at 30 weeks of age, which is when infestation was expected to peak, and then we went back and we collected our behavior observations. So we used focal continuous observations completed across 2 consecutive days across different ages. At 20 weeks, this was our pre-infestation phase, 30 weeks was the peak of infestation, and 40 weeks was our declining infestation period. We observed behavior from 6 to 6:15 a.m. and from 2 to 2:15 p.m. And in total, we had 60 hours of continuous behavioral observations. All of our stats were run in SAS, where we used proc-glimics and a general linear mixed model to calculate the least squared means and standard errors for our behavior durations and our frequencies. Our data were considered significant when p was less than 0.05, and the letters that I'll have on my graphs are going to indicate the significance of less than 0.05. For our timeline, our birds were hatched at 1 day of age. They were moved into their pullet floor room at 8 weeks of age. At 17 weeks, they were moved into the layer house where they would remain for the rest of the study. We recorded our video at 20 weeks. Our hens were infested at 24 weeks. And then we again recorded video at 30 and 40 weeks of age. This resulted in us having a pre-infestation and a post-infestation period. So getting into our results with our frequency differences, for our frequency of behavior at 20 weeks of age, this is going to be before our hens were infested, we were able to see interaction effects. So starting off with eating, for the hens that would go on to have a high infestation level, they were eating more frequently in the afternoon than they were in the morning. When it came to foraging, we saw a difference with our low group, where our low group was foraging more in the morning than they would in the afternoon. Looking now to 30 weeks, which is going to be our peak of infestation, looking at eating behavior, we again see this difference in the afternoon, but this time it's between our infestation levels. Our high birds are eating more frequently in the afternoon than the low birds are. When it came to foraging, we had differences where our high birds foraged least in the morning compared to any other time point or with our low group. And finally, with environmental pecking, it's going to be it's going to be in the morning looking at our low birds and our high birds. So our low birds are environmentally pecking more frequently in the morning than our high birds are. And finally, at 40 weeks, at our declining infestation period, this is where we see the most variation. So again, with eating behavior, we see once again in our high group that they're eating more frequently in the afternoon than they are in the morning. When it came to standing, we see that our high group is standing more in the morning than they are in the afternoon. For walking, this switches over to the low group where they're walking more frequently in the afternoon than they are in the morning. With environmental pecking, this difference is within our low group, where our low group is environmentally pecking more frequently in the afternoon than they are in the morning. And finally, our last one is going to be preening, where our high birds are preening more frequently in the morning than they are in the afternoon. This is the only time that we actually saw a preening difference on this study, which was a little bit disappointing for me, but I have some thoughts on that later. So that is it for our frequency data. Now I want to get into our behavioral differences. And I'll tell you right off the bat that we didn't find any behavioral duration differences at 20 weeks of age. So starting off at 30 weeks of age, this is not going to be an interaction. This is just looking at the difference between infestation level. Interestingly, we found that our low birds were gentle feather pecking for a longer period than our high birds were. Now, looking at the scale on the y-axis, this is a duration in seconds, so this is only about a 1 second difference. So my inclination is more that there is a single bird who really liked to gentle feather peck and not necessarily something seen across low birds. But because we had a smaller sample size, it was more likely to show up in our statistical analysis. But moving on to other 30-week data, looking at the interaction between infestation level and time of day, we again see this difference with eating behavior, where our high birds have not only ate more frequently, but they're also eating for a longer duration in the afternoon than they are in the morning. When it came to environmental pecking, this is within the morning period, our low birds were environmentally pecking for a longer time than our high birds were. And finally, with walking behavior, this is localized to the afternoon, where our low birds are walking for a longer duration than our high birds are. At 40 weeks, with declining infestation and our duration of behaviors, we only saw a difference with standing, where our high birds were standing for a longer period of time in the morning than they were in the afternoon. Now, I want to share some data on what our fowl mites were doing at this time. So when it came to our infestation level, our focal hen median mite scores did differ over time. I placed gold stars at the period where we were assessing videos. So at 20 weeks and 41 weeks of age, the focal hens had a similar median mite score. So their biggest difference in median mite score was going to be at the peak of infestation of 30 weeks. So in theory, this is the best chance that we have to see a difference in behaviors. When it came to the overall mite population, while we anticipated a peak at 30 weeks of age, our data suggests it actually might have peaked a little bit sooner than that, between 28 and 29 weeks. Northern fowl mites are expected to peak within 4 to 6 weeks of infestation, so this is suggesting that they reached that point in 4 to 5 weeks on our study rather than 6 weeks like we were predicting. But still, we had a relatively higher mite infestation level during our peak at 30 weeks than we did compared to before we infested our hens and also at the very end of the study. We had a pretty sharp decline at the end, but this was likely because the end of that study came about in June in Indiana. It got quite hot, and so it's quite possible that the mites died because of the heat and not because of anything going on with the hen. So as we look forward and as we move into our cage-free egg production, we're going to need more research into ectoparasites. What we're trying to accomplish on this study is identifying what makes a good host. So what we were able to see in this portion was that behavior duration differences were most apparent at the peak of infestation, but our frequency differences had the most variation at declining infestation. And when it came to preening behaviors, this was the only grooming behavior we were able to notice, and it only differed in frequency at 40 weeks. This brings me to the limitations of my study. The amount of video observed, as anybody who watches video, you know it's really time consuming. So honestly, we just need a bit more data to be able to look more into this. I also want to think of time of day considerations, where the times I selected were based off of what the hens were doing. Especially in the afternoon, I was hoping to capture preening behavior, so I selected a time of day where the hens should be preening. The problem is, because of that, they probably were going to preen regardless of what was going on with their mites, so that could be why I didn't actually see any differences. And additionally, our differences were only found in frequently occurring behaviors or behaviors with long durations, which again points to our sampling size things. What we're hoping to do now is we have more data off of our second replicate, where we will be adding another 30 focal hens to the analysis, which is going to be about another 90 hours of video watching. We can also turn to alternative methods of behavior observation. Like we have some accelerometer data that we can also use to try to code in their behaviors. So this will be something I'm working on next. I want to bring your attention to this graph. What we're hoping to do in the bottom right corner here is target the breeding program aspect. So my study wants to hone in on both the immune response and the behavioral response of infested laying hens to see if we can better manage fowl mite infestation. So how does this all fit into the bigger picture? This is part of ongoing work to identify heritable traits and individual characteristics associated with ectoparasite resistance and resilience. The cool thing is that these findings can be applied across species. When we have similar parasites with similar ecologies and that are common across our production species, we have some really high translatable practices. This can be integrated with existing pest management plans as this helps form the basis of pest management. And overall, this is going to help prevent negative effects on productivity and welfare without contributing to the growing pesticide resistance issue. With that, I just want to thank my lab mates and shout out Elena Scully from the Brito Lab for her help on this study. Our hens were donated by Highline International, and this work was supported by USDA NIFA. Thank you so much for listening to me, and I'll take any questions if you have any. Thank you.
Thank you, Haley. That was a really interesting talk. We have a couple questions. A couple of folks are asking, how long can mites live without a host?
That's a good question. So you would think it would actually be a short amount of time. One of our collaborators, Dr. Amy Murillo, she's seen that they can reside up to 5 weeks in the environment without actually having a host to feed on. The actual life cycle of a mite is only about 3 to 5 days, but because they can continue reproducing, the infestation can still hold on even when there's no chickens in the room for over a month. It's kind of crazy.
Great. And then we have time for one more quick question. A couple of folks are wondering if you measured any production traits like egg production or feed conversion ratio, and did that have any connection to any of the behavioral measures or mite infestation?
Yeah, so we did look at egg production. The thing about my study is I didn't have a treatment group, and I know anyone who does laying hen research, we're all trying to figure out how to individually track egg production. So I don't have a way to tie back my egg data toward birds that had a high infestation or a low infestation level. There is a lot of previous research looking at it where it's mainly a reduction in the overall number of eggs, not so much the egg quality aspect. And it is going to be increasing feed production, or sorry, the feed conversion ratio, because the hens are going to have more energy intake to try to offset the infestation that they're not putting into their production with their eggs.